Down to one last video here for section 9.2. Uh, Thanks for sticking with me if you have this far. I know that it's not easy to do these notes, they are kind of boring, but hopefully you can learn the process and you can do what you need to do. Right, if you happen to still be listening and paying attention, if you want to send me an email right now to say hi to my coworker Rory over here, my dog. I spell it like Rory McIlroy, the golfer, although she's not named after him. If you want to send me an email like that, I'd probably give you bonus points because that means you're doing what you're supposed to be doing. Now, understand, don't tell everybody about that. If everybody sends me an email, then I doubt everyone's watching their notes. So when it's only like a handful of people, I'm definitely willing to give out bonus for that. But got one last problem to do. Try and make it quick and painless, right? Just get through this. So sodium peroxide reacts vigorously with water in the following unbalanced equation. So I got to balance it first. Looking at this, sodium's not balanced, so I'll put a 2 here. Now my hydrogens and oxygens aren't balanced, so I have 2 hydrogens plus 2 more is 4, so I need 2 waters. And that fixes my oxygens. There's 4 on both sides, so everything should be good. 1 to 2 to 2 to 1. I'm given a problem here. What mass is produced when 50 grams of sodium peroxide react? So this is going to happen eventually. I have grams and I want a mass. I want grams. So this is that long problem, right? Every time you go through this, I do want you to write down, or at least when you start, I want you to try and figure out what you're supposed to be doing, right? I need to change grams of A, which is sodium peroxide, into grams of B, which is hydrogen peroxide in this case. But I have to do multiple steps to get there, because I'm going to have to change grams of A into moles of A. And then I'm going to have to change moles of A into moles of B. And then I can change moles of B into grams of B. Unfortunately, there are no shortcuts for this, so you have to do all of that work every time. But notice, not actually every time, because all the other problems, we only did part of this work, right? Because in one problem, you started from here to get that, right? The very first problem we did was just a mole-mole ratio, right? And then we did problems where you started with moles of A and you wanted grams of B, so you only did that much, right? But then our last problem we had was actually from grams of A to moles of B. And this problem just happens to be the whole thing, all the way from grams of A all the way to grams of B. So again, that might make it a little confusing, but you always basically start out with this format. If you write this grams of A, arrow, moles of A, arrow, moles of B, arrow, grams of B, and understand what that is and what we're going to use it for, you can use it every time. Just understand where you're starting and where you're finishing. Because I'm not always going to do all 3 steps, right? But in this case, I'm going to need to. I'm going to have grams of A here, and moles of A here, and moles of B here. And so that means that I have 3 different things going on, right? I'm going to have to use a molar mass for A. I'm going to have to use a mole ratio with A and B, and then I'm going to need a molar mass for B, right? So some of those things I know already, right? I actually know the mole ratio already because sodium peroxide and water, that's hydrogen peroxide, sodium peroxide and hydrogen peroxide are related in a 1-to-1 ratio, right? But my molar mass for A, 1 mole of A, I don't want to write A actually. A is a thing, it's that sodium peroxide. So I add up those pieces, 2 sodiums, 2 oxygens, and it's a mass of 77.98 grams, right? But notice that I'm also going to need to know, okay, down here it says water. I'm going to have to come up with that too. I might want a mass of water eventually because I'm not just going to do grams of B when it's all said and done. I also need to know how many grams of C are formed. So I'm going to do 2 different problems, obviously, to get those 2 different answers. but we just got to do one thing at a time, right? In this case, B is hydrogen peroxide. Again, like I said, I'm also going to need to know the molar mass for water because I'll have to use that for the other problem, but definitely need the hydrogen peroxide right now. Hydrogen peroxide has a mass of 34.02. You guys probably remember water is 18.02 because we used that a lot before. Maybe you don't, but add up the pieces on your periodic table, you get these different things. Like I said, in this problem, I'm only going to use the masses for sodium or hydrogen peroxide and sodium peroxide, but I'm also going to use water in another example here. So again, just start out with what you know, 50.0 grams of sodium peroxide, and you're going to change that grams into moles. So you use that molar mass. 1 mole of sodium peroxide is 77.98 grams. So I'm actually going to go ahead and get an answer here because I'm running out of space, but I'm also going to do that for a different reason. You'll see in a second. So if I divide 50 by 77.98, I'm going to get an answer here of apparently 0.64119 on my calculator. And I did that for a reason, actually. Sometimes it's easier to do one step at a time. So some people will actually prefer to do that. You can change grams into moles first, get an answer, and then change moles into a different mole. You can do a separate conversion each time. You should be careful if you do that. See how I wrote down 1, 2, 3, 4, 5 sig figs for my answer here? I'm not going to round until I get all the way to the end. And I'm going to make sure I have plenty of sig figs right now. 5 is more than the 3 that I need, so I should be fine. Plus, if you look at your calculator right now, it's actually pretty close to exactly that 9 at the end. So I'm not really rounding a whole lot right now. It should be fine. But then I'm going to take that and turn it into my next answer. And again, I kind of did this for a reason. 0.64119 moles. Right now, my label is sodium peroxide because, again, I had some labels canceling here, but it's still A, right? My next step in this case is a ratio of B to A, and according to up here, my ratio is a 1-to-1, right? So I could actually skip this step if I wanted to. Now I'm going to write it in because you guys should learn to recognize when you can skip it, when you can't, right? I need to change from one label to another, so I'm going to put the appropriate label in the right place, put sodium peroxide on the bottom. But that 1-to-1 affects nothing, right? Multiplying by 1, dividing by 1 doesn't change anything. So really I could have skipped a step and just gone straight to, okay, my molar mass for hydrogen peroxide is that 34.02 grams per mole, right? Now I have labels canceling all across the board to get me what I need, right? I should be able to get an answer of grams for that hydrogen peroxide. So 0.64119 times 34.02 on my calculator gives me an answer of 21.81. And again, I only need 3 sig figs, so I'm actually going to make that 21.8 grams of hydrogen peroxide. So again, that's just my first answer. Now, the second reason I broke things up, other than running out of space and showing you that sometimes you can skip some steps, right? I know that I'm going to try and come up with a different gram value here. I know that I'm going to need to also know what mass of water is needed. So I knew that I was going to have to do this first step, changing grams of A into moles of A again, right? So I decided I'd only do it once, right? You can do the whole thing over and over again, but I need to go back through and I need to change 1 mole, right? Excuse me, I need to change grams of A back into moles of A into moles of C this time instead of moles of B and turn it into grams of C. But if I already did that once, then I don't have to do it again. I could skip that step, right? So I'm actually going to start with moles of A because I already calculated that. And I'm going to change that moles of A into grams of C. So I'm just trying to shorten my work a little bit. It's not a lot, but it's a little bit shorter so it can be useful. This time again, I'm going to use a different ratio, right? So from my equation, I'm trying to relate this time my water to the sodium oxide, right? So I need a different ratio. It's 1 to 2 this time instead of a 1 to 1, which means I don't really get to skip a step in that case. But again, I'm going to do a ratio, and then I'm going to use a molar mass. Again, I already came up with that because I knew I was going to need it. My molar mass for water is 18.02. So I'm going to put that in that part of my work. But again, since I shortcutted, I'm going to start with 0.64119. Of that sodium peroxide. I'm going to change into moles of water this time, and it's a 2 to 1 ratio, 2 moles of water over 1 mole of sodium peroxide. And then I'm going to multiply it by that 18.02 grams per mole for my water. It should give me the answer I want, a mass of water. And again, just to double check, it is 2 waters over 1 sodium peroxide. I wanted to make sure I didn't do that wrong. So multiply these numbers, 0.64119 times 2 times 18.02. My calculator gives me 23.108. Again, I only need 3 sig figs, so it's actually 23.1 grams of that water. Add that on there, right? Now, understand there's a fourth thing in this too, right? I could always come up with a mass of sodium hydroxide that's going to be formed as well, right? But actually, I might do that differently. So I know this is extra, but if you guys would bear with me, I can show you something that's really important for you to understand, right? I can do that last problem differently, right? I can start with the 0.64119 moles of sodium oxide, and I can do a ratio. It's going to be a 2 to 1 again because it's 2 moles of sodium hydroxide for every 1 mole of sodium peroxide that react. And then I can use a molar mass. Sodium hydroxide, its mass is 40.00 grams per mole. Remember that because I use it a lot, but also it's a whole number, surprisingly. That doesn't happen very often. But I can do this to come up with an answer, and you can go ahead and do that on your calculator if you want real quick. But I can also just use the numbers that I've already come up with. Right? I started with 50 grams of sodium peroxide, and that 50 grams reacted with 23.1 grams. Of water. And I formed, what was it? 21.8 grams of hydrogen peroxide. So if I wanted to know the value, the mass of sodium hydroxide, I could just add up those first two things, 50 plus 23.1, and then subtract 21.8, because there's a certain law in science that allows me to do this. you can't create or destroy matter, so there better be the same mass on both sides when it's all said and done. So no matter how I decide to solve for x, and you can check this if you want to, I can add these two pieces up and get, what is it, 73.1 and subtract 21.8, and that's going to give me an answer of 51.3. That would be my value for x here. Turns out when you take 0.64119 times 2 times 40, you'll get the exact same answer. Now it might just round to this answer because it won't be perfect. We have sig figs for a reason though, right? So one way or the other, you get the same answer. And understand, sometimes you can shortcut like that. If you already know one thing, you can probably figure out the other one if you know how to use a certain law. So that's our last example. Gave you a lot of stuff there, I understand, for this section, but you can do it.